So this is a short video for IGCSE biology, section 10.2 in the book, section 10 in the syllabus, disease and immunity. In the first part we went over different types of pathogens and our body's physical defenses. And in this little video we are mainly going to be talking about extended stuff, which is how the immune system deals with this. A short disclaimer: what I'm going to be saying in this video is very generalized, and if you study medicine or anything higher, you're probably going to realize there's many more steps to it. This is just a very basic understanding on how the immune system works. There is much more to it. Okay, with that disclaimer, let's move on. So here we have a pathogen. It could be a virus or a bacteria. It got through our defenses and now it's roaming around in our body. And it wants to multiply, it wants to have fun and make us sick. And the body has different ways of dealing with it. It could run into a phagocyte, a white blood cell, and if it recognizes that this is something that shouldn't be there, it can go in and digest it with enzymes, more or less eat it. Or specific parts of my antigen here, antigens are part of the pathogen that can be recognized by antibodies. So antibodies, if they recognize it, will then attach itself to the antigen part of the pathogen, and that can either go in actively, go in and kill, or it can make it a target for the rest of the immune system, but can slow down reproduction. Now, at any given time there won't be that many antibodies floating around in our body for that specific antigen and pathogen. So over here we have our lymphocytes in the immune system, and if there is a pathogen running around, eventually my lymphocytes here will start multiplying and start producing more antibodies, who then can go in and attach themselves to the pathogen's antigen part. And hopefully that will eventually slow down or stop the infection. It will look something like this on a time scale. So here we get the infection, and the bacteria then start reproducing. Now, in the beginning here, our immune system won't be ready for it. So there won't be that many antibodies for this bacteria in my bloodstream. As the amount of bacteria rises, this will probably be around where now I start feeling sick. And up here I'll be really sick probably. But here also, the amount of antibodies will really be going up. And so they'll start to combat the pathogen, they'll start fighting the infection, and over time, well, the infection will start going down, and eventually the amount of antibodies will peak as well, and then that will start to go down as well. That's a generalized view on how it can go with diseases like this. Now, if I had the disease before, some memory cells will save the blueprint. And if I get that infection again, my body will know it. So in case of a reinfection, a secondary infection, the bacteria starts growing, but at the same time they do that, the immune response is a lot faster, which means the amount of bacteria will never be high enough for me to probably get sick. So if we have a memory cell that remembers this pathogen, the proteins on the surface, it will stop the infection from getting as bad the second time. This is one of the processes that leads to us getting immune to a virus or a bacteria. So how can we gain either full or partial immunity? Well, we can have the disease and survive it, get well. Beware, there are some diseases who hit the immune system. There's HIV/AIDS, and they don't get any immunity. There are some parasites like malaria, we will never get full immunity. Or we can get vaccination. The vaccination is where we get a version of the pathogen that is not dangerous, but still enough that our immune system will remember it. We also differentiate between active and passive immunity. Active immunity is either having the disease or having the vaccine, and thereby having memory cells that know this disease. And passive immunity either comes from breastfeeding, you get antibodies from your mom, or you can get antibodies injected specifically for that disease, which can then help combat the disease. But in both cases here, you won't have the same effect on the memory cell, and you won't get any partial or full immunity. This is very simplified, but I hope it can help you in some way. Thank you.